It is 2 hours UTC, and here we are, Astronomy Daily Live. So this is a daily live stream. We talk astronomy for a certain amount of time. I'm trying to knock it down to between 30 and 45 minutes, but sometimes it goes a little bit longer. Maybe sometimes it'll go a little bit shorter. So, hey, everybody. Hope everybody's doing okay out there in the world, on the world. We're not exactly in the world, we're just sort of, on top of it a little bit. Interesting article came out in archive.org today. Now, I've described archive.org as sort of a preprint clearinghouse. Once papers have been accepted for publication, then they're, at least what I've been saying is that then they're sort of okay, they're allowed to publish on archive.org. And I've also talked many times about the process that authors have to go through in order to get published. And I might have to amend that. I'm going to have to read, because maybe things have changed a little bit. But that process does not apply to this paper that appeared on today's archive.org. And I just like 5 minutes ago saw this, maybe 10, for the first time. So I haven't even been able to post it to my Discord server yet. But what I want to say is that you may not hear this news anywhere else, but you are going to hear it here. And that's one of the cool things. It's one of the side effects of having, whoops, of having a daily live stream. And that is keeping up on the latest bleeding edge news is really snappy. I can sort of scoop everybody else. Um, that of course isn't the intention. It's just an effect of this. So, but remember a couple of weeks ago, there was a big story that at least all the podcasts that I watch covered, and that is that they found a galaxy with no dark matter in it. That was sort of the headline, and I forget exactly what the title of that paper was. Be able to look it up here quickly, because I think I put it on my Discord server as well. Is that a true statement? Let's see. It was a little while ago. It was a little while ago. Maybe I didn't post it. Maybe I didn't post it. I don't know. So we'll have to look for that one to get the actual title. But the headline was this galaxy has no dark matter. There was another article a couple of weeks prior to that one, as you recall, where that the same system called Dragonfly, which yeah, is another awesome system, um, telescope system. Uh, they had discovered a galaxy that was almost all dark matter. Okay, so first story that broke maybe a month or so ago. I don't remember exactly. Everybody gets all excited about dark matter, and let me tell you, folks, I don't think so. I don't think so. We are overlooking something extremely obvious, and so to attribute that uh, to so-called dark matter. The skeptic in me just has a really, really, really hard time with that one. It's this thing that we can't detect and can't see, yet can see its effects. And you know, there may be other explanations. There may be other explanations. We need to, you know, get out of this box. Get out of this box. Expand the volume of our box a little bit, and consider consider that there may be other forces at work there that have nothing to do with mass or matter in any way whatsoever. And yeah, yeah. So I think there are ways of looking at that in a different way. But anyway, so they found a galaxy that was almost all dark matter. Okay, all dark matter. And then a couple weeks later, they found a galaxy that was almost no dark matter at all. And so everybody, because it's dark matter and because it's so strange, either all dark matter or no dark matter, that pretty much covers the whole thing. Um, so everybody was pretty excited about this. Let's see if anybody gets excited about this article that I just found on archive.org. It is called Current Velocity Data on Dwarf Galaxy NGC1052-DF2 does not constrain it to lack dark matter. So I will post this paper on my Discord channel, which you can see a link to down in the description down there. But let me just let's pull it up over here so you all can read along. There's actually quite a few things that can be talked about tonight. I definitely want to talk about one topic because it's sort of like a story time. So let's go over to archive.org. It's ARXIV. That's the X is supposed to be a Greek letter chi, and so it's archive.org. There's also an alternative to archive called, I don't know if it's called Vixra or Vikra, but Vikra is just archive backwards. So it's vixra.org. And you can find additional articles that are, maybe a little bit further out into the fringe. But you know what? Everything at one point was fringe. Everything that we hold to be known and sure of and true and everything else was once so fringe it never even got thought of, right? So yeah, I encourage fringe thinking and fringe investigation because you know if nothing else, it sort of gives you, the reader, a different perspective on things. And you can decide for yourself how you're going to deal with that kind of information. Are you going to just, slough it off because you think it's the most ridiculous thing you've ever heard? Or, are you going to be like, oh, well, yeah, that sounds exactly right. So, yeah, I mean, it can go lots and lots of ways. So, anyway, archive.org is very, very awesome. And as I said, I just saw this article right before going on, on live here. So I'm going to find it again. I've got it pulled up on my Linux machine, but that's way over there. Oh, here's another one, Mond and the dynamics. So they're trying to apply modified uh, Newton's laws um, to that same object, but I didn't see that until now. So everybody's pretty excited about this galaxy with so-called lack of dark matter. It's got a lot of people excited, and that's while I'm looking for it here. That's the thing that I wanted to mention about. I'm going to have to look into archive a little bit more because I thought that these were all preprints. These were papers that have been accepted for publication but haven't quite been published yet. And to come out with a paper, oh, where is it? I don't remember where I saw it now. Well, let's do this. 1052. There it is. So, yeah. So, current velocity data on dwarf galaxy NGC1052-DF2 does not constrain it to lack dark matter. So let's just read through this just for fun. It was recently proposed that the globular cluster system of the very low surface brightness galaxy, NGC1052-DF2, was dynamically very cold, leading to this conclusion that this dwarf galaxy has little or no dark matter. Here we show that a robust um, statistical measure of the velocity dispersion of the tracer globular clusters. Now, when that just sort of brings me off onto a little bit of a tangent. You know, when we're looking at these dwarf galaxies, we're not seeing individual stars. They're too small, too faint to really see individuals, but we can see globular clusters that populate that dwarf galaxy. So we're already sort of extrapolating from a globular cluster in at least what we think we know about them in a different galaxy, and using that to extrapolate and come to some conclusions. So we're not actually really measuring the mass of the galaxy. We're looking at the number of globular clusters. We can look at their spectra and get an idea of what they're made of, which means we can get an idea about how much stuff there is in them, and that relates to mass. So but it's a few jumps, right? It's a few jumps. Anyway, so they say that here we show that a robust statistical measure of the velocity dispersion of the tracer globular clusters implies a mundane velocity dispersion and a poorly constrained mass to light ratio. Models that include the possibility that some of the tracers are field contaminants do not yield a more constraining inference. We derive only a weak constraint on the mass to light ratio of the system within a half light radius or within the radius of the furthest tracer. Typical mass to light ratios measured for dwarf galaxies of the same stellar mass as NGC 1052-DF2 are well within this limit. With the study, we emphasize the need to properly account for measurement uncertainties and to stay as close to possible to the data when determining dynamical masses from very small data sets of tracers. So that's what this is. This is a criticism of the analysis that was done, and then declared that this galaxy had this odd property. And what these folks are saying, let's see, where are these guys from? Usually have a thing down here. So looks like University of Strasbourg, Max Planck, University of Surrey, and STSCI. Okay, all right. So quite a spread in geography there. But what they're saying is that really you guys don't have enough data to come to that conclusion. And the purpose of this paper is to sort of show that it's like we really don't have enough information to come to that kind of a conclusion. I want to be watching this on my smartphone, so I'm going to pull that up. I seem to forget something. There we go. So anyway, I just think that's an interesting piece of news. The saga continues, and I may not get incredibly into depth with these things, but I think part of what this daily thing is to keep everybody just sort of on top of things. Inform, discuss a little bit, uh, as much as I think I can or have time for. So, but I think it sort of it gives you a very, very, very brief introduction into the subject, and then you can go read the paper, you can read other articles about it, and most likely you'll hear about this hopefully in the next few days, um, because now it's sort of like, well, I don't know, doesn't seem to be enough information. Doesn't seem to be enough information. That's sort of what it says, and this is uh, this last paragraph, right, seems to sum up their whole thing. The different conclusions reached by VD18b, which is the reference to the original paper, and this study show the difficulty in extracting information from a small velocity data set. See, so they're just measuring the velocity. Oh man, yeah, they're not even looking at spectra. Wow. Especially when the measurement uncertainties on the individual data points are of order uh, of the dispersion that is being inferred. So, it's like 1 plus or minus 1. so, so, not a lot of precision there, right? Pretty poor precision. They may be dead on in terms of what number they get, but their precision is extremely poor. So you can't know how good your accuracy is if your precision is really poor. So yeah, in such cases, reverting back to the simplest model and techniques using a generative model yields more robust and tractable results. So there you go. You heard it here first. Hey there, Tom. Hope everything's doing well. I just popped on onto the chat. No. So both of these terms continue to. Uh, I I would think so. I think this kind of paper is really awesome, right? Because um, most of the time, these kinds of discussions are being done, over dinner, during lunch, at a conference, um, you know, at a bar, whatever, right? And uh, you don't get a chance to, well, it's sort of, it's not incredibly rare, but I mean, it's relatively rare to see sort of an open and public scientific discussion where, you know, one group says A, B, C, and the other group says, no, it doesn't look like it's A, B, C. It looks like it's something else. We don't know. There's not enough data. So, but yeah, I would think that, you know, it seems as though uh, this system, and I haven't heard anything about the other system, the one that's supposed to be all dark matter or mostly dark matter. Um, haven't heard anything about that, but you know, dark matter is sort of the exciting thing right now, regardless of what it actually is. Which I mean, I think when we figure out what's going on and we sort of agree, then I think it's going to be quite an extraordinary time for astronomy and for lots of things, lots and lots of things. Um, but yeah, I think people are going to be observing these things. I think um, if it's true that it's all they've done is measure the velocities of globular clusters, and from that have inferred a mass of the galaxy itself. I don't know. That's a pretty big stretch, I think. Um, yeah, that's a pretty big stretch, and it's what, a sample of 13. So it's not enough data, and you're really stretching, really stretching. So anyway, just a heads up, I will, as I said, I will post this article on my Discord server, or you can just go to archive.org and find it that way. But I think this kind of stuff is just fabulous. It's you know, a little bit of like drama in the astronomical world. You know, regardless of really, you know, the subject matter. Don't really care. You know, it's astronomy, so it's cool. Cheers. So yeah, I would think that these teams would want you to follow up. They're going to be wanting to take spectra, because with a spectrum, you can, you know, uh, you can gather a lot of information. Um, going to be doing, you know, photometry, some hopefully some longer exposures so they can see fainter things, maybe be able to pick out individual stars. Or if nothing else, you know, with long exposures, you put a spectrograph on that, take a look, you know, see what's going on. Um, so yeah, I think you know, look, honestly, everything out there is extremely interesting and needs to be studied more, right? Um, it's just it everything is such a mystery, and so we just need to we just need to keep looking, and yeah, it's fun, you know, it's fun. So really, what I wanted to talk about tonight is another little story time of sorts. Um, this is the 30 today is the 37th anniversary of the launch of Space Shuttle Columbia, April 12th, 1982. Was it 82? That was 81. Hmm. I thought it was 1981. Let's just check this out, because I saw the 36th, no, 37th anniversary. That's right. That's right. I'm doing my math weird. Okay. 37th anniversary, April 12th, 1981. Now, I heard about the space shuttle program probably I want to say about 1977 or so, 1977, 1978. I was um, I was 8 or 9 years old at the time, and I I had heard about Viking. I'd heard about, them landing on Mars, and I remember seeing some pictures, and not really grasping the awesomeness of what was happening. I certainly was aware because I was very, very interested in those kinds of things, but I really didn't. It didn't hit me too hard. It was just like, okay, I mean, I'm sort of interpreting my thoughts now, and it's sort of like, okay, they've got a lander, they're taking some pictures. Pictures look, I don't know, you know, rocks, dirt, sky. Okay, it's cool. It's cool. I I care. It's not as if I'm not interested or anything, but it was just like, oh, that's cool. So anyway, around the same time, I heard about this concept of a like a space plane, a space shuttle, and I have absolutely no idea how or when I saw the first sort of drawings, artist impressions, that kind of thing. But of course, I saw that, and I remember at the time when I heard about the shuttle, the first launch was scheduled for, I believe it was 1979. 1979, and as I said, I think I heard about this in maybe 1977 or so, and I'm like, oh man, that's 2 years away. I've got to wait. I've got to wait for 2 years, and for this thing to go. I mean, I had no concept, right? Absolutely no concept of what goes into uh, this kind of a device, right? No concept at all. It's like, oh man, I've got to wait 2 years for this thing to launch. Awful. So uh, I think it was soon after that, for reasons that I never bothered to find out. I could definitely go and find out now. But the launch was postponed. It was postponed and postponed and postponed. Just um, every couple of months, it was just pushed back and pushed back and pushed back and pushed back. And I mean, as a kid on the almost exact opposite side of the country from Florida, I was in Washington State at the time. Um, uh, yeah, it's like, okay, well, you guys just you know do what you got to do, and light that candle, right? Cheers. So after 1979, when it was so disappointing when it started to get pushed back and pushed back and pushed back, that's that's when I really got excited about it, because I mean, maybe it was like a PR stunt, right? It's like, let's hold back for a few years so people actually get interested in this. It's 1979 and nobody cares. Nobody cares. But if we postpone it, oh, it's really difficult, and we're having some problems, and we lost some screws, and you know push back and push back and push back. What people don't have, they want. And so it could be it could have been a grand conspiracy just to get more attention, and more public attention means more public money. So no, probably not. But yeah, they encountered problems. The space shuttle, honestly, is a work of science fiction, right? It's a really great fantasy idea, but um, it's an engineering nightmare. It's just and it's really pretty stupid. It's pretty stupid to have your payload be on the side of your rocket. It's just, oh, that's just, uh, you know, but for sci-fi, the space plane and all that, and the space shuttle, the concept of the space shuttle, I'm sure goes back at least to the 60s, if not earlier. And then again, as sci-fi, yeah, rocket planes and all of that. So I get it. I understand where the influences are coming from, but to force to, I mean, it's that was engineering by brute force. That's all it was. And I remember very well. I remember very well when the when the first few shuttles started going up, they started to talk about failure statistics. And I believe that NASA came out with a number that was 2%. There's a 2% chance of some kind of catastrophic failure. And yeah, they were really close. They were really close. So, uh, you hear that number and it's like, oh, that's pretty good. That's pretty good. Is that worth the risk? Yeah. That's another thing that I think too, is that, as terrible as those accidents were, um, those people knew what they were um, dealing with. They knew what the risks were. They were well informed. They were well informed. They don't. I mean, most of that training is to let them experience things that they normally wouldn't experience, but will be common experiences in space. And knowledge is power. So they knew very well what they were getting into, and with very well informed minds, made the decision to go for it, right? Um, so you gotta admire that kind of thing, because you know uh, rocketry is not going to be safe and reliable for quite a while. Um, it's just it's a little, I think it's a little too much for us yet, and so sometimes it gets away from us. And I don't know if that's going to change anytime soon or not. I think I guess it's just going to take practice, and practice does make perfect. There's always going to be accidents, always. You have to accept that. You have to accept it and go with it, and also realize that if you're involved, it's your risk too. So is it a risk that I would take? Mm, I think in the situation that I'm in at the moment, I would be hard pressed to just voluntarily go. I think if there, just for the experience. Um, But I don't know, because actually one of my life goals is to take a 1 week vacation around the moon. I want to, basically do the Apollo 8 flight, and that'll take a couple days there, a couple days back. So launch, orbit for a day or two, fire your, strap in, fire your rockets, go around the moon, right? Go completely around the moon, look back at the Earth, you know, put your thumb over the Earth, and have that experience of being really far out, and then come back and splash down whatever it is, um, you know, whatever's easiest, whatever's most reliable, I guess. And yeah, a week's vacation, I might do that. I might do that. If it's just a thing where it's sort of up and down, nah, that's not enough. That's not enough. Um, yeah, yeah, not quite enough. Anyway, so the shuttle. So from 1979 to 1981, I just got exponentially more and more and more and more and more and more excited about the shuttle launch and the whole shuttle program. So I found books on it, and I just absorbed everything that I possibly could. Read all the articles that I could find. You know, by 1981, I was um, I was 12. I was 12. So yeah, I think I'd found the main library by then. So I probably got a lot of information there. Um, Probably. Of course, there wasn't a internet, not like now, at least. 1981, pretty sure that what ARPANET um, was probably up and running. Um, Probably military networks, maybe government networks. But the first real internet was .edu, right? It was all the schools, all the universities, all the colleges. That was the first network, really. And soon after that, it started be calling Ethernet, and then yeah. Anyway, how did I get off on that? Um, so yeah, I was um, 12 at the time, very, very excited. I had gotten this book that described, it was sort of a kids level book, teenage level book, um, that described what I thought were some pretty intricate details in terms of like the launch profile. You know, at T-1 hour, they start filling the tanks, and at T- this, they start doing this, and it's a countdown to zero, and then at T- 57 seconds, it's max Q, and um, I'm 220 into it. The SRBs separate, and 10 minutes they have MECO, and the external tank separation. MECO is main engine cutoff, MECO. Uh, so yeah, just having all those details and going over them over and over and over in my head, the sequence. So when it comes to watching this thing live, it's like, okay, and then launch date comes, and now I don't remember exactly how this all went down, but I'm going to give you my impression. Okay. Um, So launch date comes. It's of course launching in Florida. Okay, I'm in Washington, so I'm 3 hours behind. So it's an early morning launch. It's 7 a.m., 8 a.m., probably 7 a.m. or 6 a.m. Florida time. So it's 3 or 4 a.m. my time. Sitting there in the dark. Uh, uh, Everyone else is asleep, and I'm sitting there with the TV on. We had it was this was also before cable, so uh, we had the three main stations and PBS. I think we had four channels, maybe five. I don't remember exactly. So they were all covering it, right? It was on every single channel. I think even PBS was doing some kind of live thing. So I was frantically, there was no remote, right? I was frantically, flipping the channels, trying to get the latest and greatest information, but of course they all had their commercials at the same time, and they were all saying the same thing because they were all hearing exactly the same thing. But so everybody's really excited, and it's going to go, and this is the shuttle, right? It's like this dream fantasy thing, engineering nightmare, but this fantasy plane that is going to uh, reduce the costs of space flight down to a level that everybody can afford. You heard this somewhere recently? Um, uh, and STS uh, stands for Space Transport System. So every single one of those shuttle missions was an STS 1 through STS 130 something. So Space Transport System. These were supposed to be space trucks, right? Space trucks bringing shit up, bringing stuff back down, just trucking, material. That was the whole idea, and because they were reusable, okay, that cut the costs quite a bit. It's a lot like what Elon Musk talks about now in terms of if you only used an airline plane once, um, you would never ever see a $39 fare to Las Vegas, right? Um, it would cost hundreds of tens of thousands of dollars at least, right? So the idea of reuse does cut costs. So it was this great concept, great forward looking uh, concept, very progressive, very very awesome. So we're sitting there, right? It's at 4 a.m. in the morning. Okay, it's dark. It's cold. It's still April, so it's still cold, right? So it's dark. It's cold. I'm not used to being up at that time. I think it's probably one of the first time. It's probably the first time that I ever did that. So it felt strange. Wasn't used to that time of day or that time of night. So I sat there, right, and we waited, and there was a delay. It's like, okay, I now, as I said, this is just my perception of things. I would have to go back and look and see exactly what what the timeline was. So my accuracy isn't going to be incredibly great, but I just want to lay the story out. So there's a delay, and then it's like, okay, we're going to launch now, and there goes the clock again, right? And then the clock stops, and they come on, and it's like, oh, there's a delay. They've forgotten to tighten a screw down, and or they forgot to fill up the gas tanks, whatever. The guy the helmet fell off, whatever, you know. So there's another delay, and then it's like, okay, we're gonna go again, and the clock starts going down, and then there's another one, and finally they're like, look, we are done. We're gonna try this again in a couple of days. We're gonna work out all these, little problems that we have, and we'll light this candle in a couple of days. So come on back. So same time, maybe a couple of days later, I think, as I recall, sort of the same thing happened. I want to say maybe 2 or 3 more tries. And then the morning of April 12th came along. April 12th, 1981. And here I am sitting, in front of the TV, right? It's all dark, it's cold. I'm, still not really used to being up at this time of night. Feels funny, all of that. And I'm sitting here watching the shuttle launch. And I don't remember if there were any delays that day, but yeah, when it lit and jumped off of that pad, and did its turn to lean over, yeah, that was extraordinary. That was an extraordinary thing to see, and I'd been waiting at that point for 4 years, to see that. And the prior 2 years, as I said, I was just on this exponential excitement curve. So the adrenaline was just as high as it could possibly be. And of course, it was a beautiful launch. I think they were up there for like 2 or 3 days or so. It was John Young and Robert Crippen. John Young had walked on the moon, which at the time I didn't know, but he had walked on the moon. Robert Crippen, I don't remember his story. Yeah, don't know his story. And so they were up there a couple of days. They went around and around, and we watched the charts. At the time, they didn't have TDRS, the Tracking and Data Relay Satellite System. They just had their ground stations. So every so often they would go LOS, loss of signal, and we would have to wait until they passed over another ground station. And sometimes it was quite a while. It takes about 90 minutes for an object like the shuttle at that orbit to go around the Earth once. So you really didn't ever have to wait very long, but sometimes it was 5 or 10 minutes at the most. It was just like waiting and waiting and waiting. But so then, yeah, they finished their mission, which was essentially get up there, open everything up, turn everything on, close everything, turn everything off, close everything up, come back down, lands like an airplane, right? Lands on a more or less a regular old runway. It can land on a regular runway as long as the runway's long enough, right? It's got to be, I think, a couple of miles long, which isn't all that long. So yeah, they then it was landing day, and it was probably, I mean, I'm not a airplane person. I'm not a knower and a connoisseur of aircraft, but even at the time, that was the sweetest landing of an aircraft that I had ever seen. I'd been to several air shows. I lived right next door to a SAC Air Force base. you know, there were those air shows were always extremely awesome, and I never been impressed. It was probably a little bit of a bias because it was the shuttle, but that landing was sweet, and it was perfect. It was absolutely perfect, and it was John Young flying it. I guess it's automatic until the last minute or so, and then he grabs the stick and pulls it in the rest of the way. And it was, and this is probably a biased opinion a little bit, but that was the sweetest landing I've ever seen, ever. That was sweet. All right. Well, I think with that, I'm going to get out of here for now. Um, that's another story time on Astronomy Daily Live. Hope you like that. It's 37 years ago today that Columbia, hail Columbia, that Columbia launched the first space shuttle. The first space shuttle, an epic mission, STS-1, John Young, Robert Crippen, and yeah, awesome. Probably the most exciting thing that I'd ever seen or experienced, and definitely in my top 10 experiences. And I've had some whoppers. So, but that was very awesome, very awesome. Again, you know, so many things happened to me at like exactly the right time to give me that fuel, right? I mean, I was already riding the rocket, right? I was on the astronomy rocket. There was nothing that was going to have me, you know, leave that rocket. But fuel, connections, cosmos, the space shuttle, they all came right at that very impressionable age, 10, 11, 12 years old, when yeah, it was just awesome. It was just awesome. So all right, I'm gonna get out of here for now. Um, yeah, you know, this this Astronomy Daily Live is for everyone, including the nerdiest of nerds, right? I think yeah, um, there was a series done. It was a computer series done a number of years ago called Triumph of the Nerds, and um, Uncle Bill and Tom, if you haven't seen Triumph of the Nerds, and if you lean towards the nerdy side of things, you'll love this story. You'll love this story. It's a 3-part uh, series on the beginning of the computer era. You know, early '80s or so. You know, when Apple and Microsoft were getting going, and it's sort of, you know, just a story of 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 that. There's another interesting book, and I'm not going to keep you very much longer. I've read it once, and I need to read it again. It's right here up on my shelf. It's a book by Tracy Kidder. Tracy Kidder. It's called The Soul of a New Machine. Now that I really need to read that book again. I have not read that book in probably 23 years. I think I read, as I said, I've read it once, and I read it about 1995 or so, when I was really starting to get heavy into computers. I was already um, programming for, you know, scientific things, but I was getting into other stuff, you know, hardware control and you know, telescope control systems and all of that. And the Soul of a New Machine is an awesome backstory, behind the scenes story of the development of a computer. So yeah, if you want to nerd out, you have come to the right live stream. Because you probably won't get much more nerdy than this. And proud. All right. Yeah, the mothership calls. So I'm going to get out of here for now. Yeah, I'll post that uh, uh, article about maybe this galaxy does actually have dark matter. We just don't know. Not enough data. So who knows? All right, I'm going to get out of here for now. I will see you on the spin about 23 hours from now. Don't get dizzy. Don't get dizzy. It's a smooth ride. You've done it a few times already, so you're used to it. All right, take care, and I will see you tomorrow. Bye.